Okay, we have written an interesting integral. This one's from the UK integration bee, sample number 12. We have the integral of square root tan x over sine 2x dx. Okay, when I first did this one, I really had no idea where to go with it. So to start, what I wanted to do is just expand out sine 2x. Using the double angle formula, we can rewrite this as 2 sine x cos x. Then from there, what I did was I broke out tangent into sines and cosines, thinking that maybe we could get a u substitution. It didn't really work that well. It was kind of a mess that way. So what I wanted to do instead was something completely different and just try to do a u substitution for this numerator. So starting with that, we'll have u equal to square root tan x, and then we'll take a derivative. When you do this, there's kind of a nice property when you take the derivative on something squared, where you can write it as 1 over 2 square root of that thing, tan x. But then we're going to need the chain rule on this. So derivative of tan x is going to be secant squared x dx. But then the trouble here is this doesn't really look that much like anything we have there. I mean, there's a couple of promising points. We have the 2. Cosine is actually bringing it into the numerator. That's going to be the same thing as secant. So we're kind of getting somewhere. What I can do with the square root of tan x, if we just take this, we can rewrite the square root of tan x as tan x over square root of tan x, just using exponent properties. That's going to create our square root of tan x in the denominator here, so that's promising. Another thing I can do with this, actually let's take it a step further. With tan x, I can split this out. So I can break out the tan x as sine x over cos x, and then we can bring in this other part here. So let's use all this and see if we can put together something that's going to look like our du. So then first we'll use this here, and I'll kind of go out of order with it, I guess. Here, like we want to have this square root of tan x. So we'll have this here, then we'll have this sine x over the cosine x for the tangent. So this is the same thing as what we have here. Then we can bring in this part here. Let me extend this. So we'll have our dx, then we're going to have all this 2 sine x cos x. But then I can cancel sine x's here. Cosine x times cosine x, let's bring it over here and write this as cosine squared x. And then just to clean it up, for cosine squared x, I can bring that into the numerator. And now we have secant squared x. Then rearranging all this, I'll bring this 2 to the front, square root tan x. But then what happened, the whole integral, everything here, this is actually the same thing as our whole du value. So we didn't actually need, there is no u, it's just all gonna be du. So when we substitute, this whole thing just reduces all the way down to just 1 du. Integrate 1, we're gonna have u, back substitute in order to finish it off. And so for my final solution, we just have square root tan x plus c. And that's it. Okay, there you have it, a good one from the UK integration bee. Thanks everyone for watching. Have a good day.